So before 1665, no one knew anything about light at all. And in that year, Isaac Newton played with prisms, stuck needles in his eyes, and came up with the idea that light is made of particles of many different colors. He put that idea forward in a book, and it led to Newton's most enduring legacy, the cover art for the seminal 1973 album by Pink Floyd, Dark Side of the Moon. So fast forward to 1801, Thomas Young, Egyptologist and natural philosopher, holds a card with two slits in it in front of a sunbeam, and instead of seeing the expected two vertical lines of light on the far wall, he sees this. It's kind of blobby, but it's a classic wave interference pattern. The bottom one is with a laser, so it's a little bit crisper. So what is a wave interference pattern? Well, it proves that light is made of waves, first of all, and here's an example of it. When you have two wave sources near each other, the waves intersect. And the highs reinforce the highs, the lows reinforce the lows, highs and lows cancel out. And you get this classic pattern. You see it in water. It works in sound, right? The waves in air. And it works in your microwave, which is why the microwave goes around, because otherwise your food would be cooked in strips. Okay, so 100 years later, someone shines some light at a piece of metal and electrons move. And no one understands it until this gentleman, Albert Einstein, figures out that it only works if light is made of particles. So he names them photons. And this is groundbreaking. He basically starts quantum physics. It foretells lasers, solar power, wormholes in space, and therefore like 90% of science fiction. So now light is definitely a wave, and it's definitely a particle. Well, so how does this work out, right? Well, we're not going to get hung up on it. We are going to accept it, and they call it the wave-particle duality, okay? And so it's just like we have a house, and Mr. Rabbit sees a white house, and Mr. Bear sees a black house, but it's the same house. And between ourselves, that is criminally simplifying the whole situation. It's not really what happens, but we have little time, so we're going with it. Okay, so then in the 1970s, scientists gain the ability to shoot photons one at a time. So they hold up a slit and they shoot photons through it. And you can see on the left, that's about what you'd expect to see, right? If you threw lots of little balls through this, you get kind of a pattern that looks like the slit. So then they did it with two slits, and you would expect to see the same thing, but just doubled if you were randomly shooting little particles between these two slits. But that is not what they saw. They saw our old friend, the wave interference pattern. Well, how can that be? You're shooting them one at a time. What's interfering with what? So we need to explore this a little bit further. So they took passive particle detectors and they put them in front of the two slits to see which way it was going through. And this, in fact, is called a which-way experiment. And then they turned the particle detectors on. As soon as they turned them on, it stopped acting like a wave. Suddenly it's acting like a particle. The pattern changed. And then they turn it off, and it immediately goes the other way. Well, this is strange. So they think, well, maybe the particle detector is not so passive. Maybe it's getting in the way of the whole thing. So they come up with some of the most gorgeous experiments ever devised by humanity. And in one of them, they measure light from distant galaxies that was sent billions of years ago. So the decision was made billions of years ago before humanity even evolved. And in another one, they don't even look at the particle at all. They look at its quantumly entangled twin in a really cool way. And the same thing happens. So where are we? Well, first off, the observer effect, observation affects reality, has been confirmed. Whatever. So the second one is that it's not just light. It happens with stuff, with electrons, with particles, with neutrons, with stuff, right? So, mind blown. This shows that what the Buddhists and the mystics have been saying all along for thousands of years is true. Consciousness is a co-creator of reality. Mind and matter work together to form the universe in which we live. It's just like the time I was doing ayahuasca in the mountains and the dolphin came and he talked to me and I was like, whoa, okay, it was great. So, sorry, I gotta take this. I apologize. What's that? All wrong, woo nonsense, complete misinterpretation. And it's like, yes, I've heard the quote from Einstein that does the moon disappear when you stop looking at it, you idiot. Oh, Einstein didn't say you idiot? That's you talking. Okay, fine. All right, so further research was done which takes consciousness out of the equation. And they basically say that the particle gets entangled with the environment. And so that lets us do a lot of cool math. You know, we have special instances of the Schrodinger wave equation and decoherence theory. It doesn't really matter. But the idea is that the environment measures things, right? Even if it's inanimate. So, solved, right? Maybe not. Because nobody can really agree on what measurement is. We don't have a way to compare this with a universe where there's no humans or no sentient ever, right? And it's like we've replaced the idea of consciousness with this vague concept of measurement as the decider. So it's a little bit iffy. So the other really big question is, if we're shooting one thing at a time and interference is happening, what is it interfering with? Well, some of the popular theories are that the interference is happening in the fourth dimension. It's time, right? So the particle is either sending information backwards in time, it's time travel, or it's interfering with future and past particles, or there's this great word, retrocausality, which means that future things cause things to happen in the past. Okay, that's possible. And then there's like the many worlds theory, right? Which is that every time a decision is made, no matter how small, the timeline splits. And so it goes through the right and the left slit, but in different universes, which are created. And after that, there's a lot more. That's when it gets weird. So probably the most popular theory is called quantum superposition. Let's take a moment. Superposition. Kind of distracting. But anyway, so what it means really is that the particle, while it's in transit, actually doesn't exist anywhere in any one place at all. It's just a wave, a combination of all the different probable paths that it could possibly take, right? And so and that's what's interfering. Anyway, so let's go back to the question. Does light know when we are watching? Well, not really. But it is true that if the system light is in changes such that there's any chance of being observed anywhere in the whole universe, it seems to instantaneously change its behavior all across space and possibly across time. So that's weird. And coming back to light for a second, is light a wave or particle? And this one I know. The answer is no. Light is light. Waves and particles are just mental constructs that we put on them to try and grasp any kind of understanding of the universe, but really, they're just models, and they're really important. And the math works, so we have cell phones, and it means, and this is the pinnacle of human intellectual achievement, I firmly believe, but it's not reality, so let's not confuse it. Thank you.